Welcome to This Explainer. Today, we're going to be looking at one of the most incredible, terrifying, and ultimately triumphant survival stories in the entire history of human exploration. Okay, let's just dive right into it. The year is 1970. It's April. Less than a year prior, humanity had taken its very first steps on the moon, right? Now, NASA is launching its third lunar landing mission, Apollo 13. The crew is incredibly confident. But what started as a totally routine flight to the moon's From Morrow crater, well, it very quickly devolved into a desperate fight for survival. We're going to break down the exact anatomy of this disaster and specifically look at why a single oxygen tank brought a mighty spacecraft right to its knees. Our story really kicks off on April 13th, the third day of the mission. Without any warning at all, a massive bang shook the entire spacecraft. Warning lights absolutely lit up the dashboard, jarring alarms started blaring everywhere. Commander Jim Lovell got on the radio and delivered a line that would literally echo through history. Houston, we've had a problem here. At first, down at Mission Control, they thought it was just an instrument malfunction. I mean, it couldn't be real, right? But up in space, the astronauts could literally look out their window and watch their precious oxygen venting out into the vacuum of space. 330,000. That is the terrifying distance in kilometers between the Apollo 13 spacecraft and the Earth at the exact moment of the explosion. To put that into perspective, they were further away from help than almost anyone in human history. The blast had actually jolted the spacecraft off its path, so they were hurtling even further away by the second. Suddenly, the entire mission objective shifted. Forget walking on the moon, the only question left was whether they could return to Earth alive. Now, you want to know the profound irony of this whole situation? It is staggering. Just hours before this catastrophic explosion, at exactly 46 hours and 43 minutes into the flight, the capsule communicator on Earth literally told the crew, "We're bored to tears down here." And you know what? The public kind of felt the same way. Unlike Apollo 11, which had, 7 million spectators, Apollo 13 only had about 200,000. People genuinely thought going to the moon was just a routine commute at this point. TV networks weren't even broadcasting their live check-ins. Spaceflight had become boring. Until suddenly it wasn't.
Section 1. The Anatomy of Apollo 13.
So the Apollo payload, launched on the Saturn V rocket, basically had four main parts. First up, the command module. This was an 11-foot-long cone where the three astronauts actually lived. Second, the service module. Think of this as the powerhouse attached to the command module, holding the main engines, fuel cells, and crucially, the oxygen tanks. Together, these two are called the CSM. Third, you had the lunar module, which was the landing craft meant to go down to the moon's surface. And finally, the launch escape system, which had already been discarded after a successful liftoff. The absolute key takeaway here is that the catastrophic explosion happened in the service module. Which brings us to Section 2, why the tank exploded. Let's get into the forensic breakdown of how a highly engineered, thoroughly inspected piece of space equipment just blows up. The doomed history of oxygen tank number 2 actually goes back much further than this mission. This spear-shaped tank wasn't even new. It was originally installed in the Apollo 10 spacecraft, but got removed for some modifications. Well, during the repair phase, it was accidentally dropped. It was a super minor drop, but it secretly damaged a tiny internal tube. Nobody saw this invisible damage, but the trap was totally set. During a later testing phase on the ground, engineers actually noticed the tank wouldn't empty completely, and that was because of that damaged tube. So, to solve the problem of the trapped oxygen, NASA engineers came up with a workaround. They decided to use the tank's internal heaters to just boil off the remaining liquid oxygen. Now, in theory, this should have been totally fine, but there was a deadly design flaw. The thermometer inside the tank was designed to max out at a reading of just 30 degrees Celsius. So as these heaters were running, the ground crews watching the dials thought the temperature was sitting at a perfectly safe, cozy 30 degrees. But here is the absolute shocking reality of what was actually happening. While the thermometers showed 30 degrees Celsius, the actual temperature inside that tank skyrocketed to an astonishing 538 degrees Celsius. Because the gauge literally couldn't read that high, nobody noticed the extreme heat. This insane temperature just baked the internal components, completely melting away the protective insulation on the electrical wires inside the tank. The engineers approved the tank for flight, totally blind to the fact that they had just loaded a ticking time bomb into Apollo 13. And that brings us right back to day 3 of the mission. The flight controllers casually ask astronaut Jack Swigert to perform a totally routine check of the oxygen levels. So Swigert flips a switch, electricity flows into the tank to stir the oxygen. But Because those wires are now bare and completely exposed from that 538-degree baking they took back on Earth, they short-circuit. A spark arcs in an environment of pure, highly pressurized liquid oxygen. The result? Instant, explosive devastation. Now, despite the absolute terror of this moment, the astronauts actually caught a piece of miraculous luck. The oxygen tanks were housed in the service module, which was attached to the exterior of the main cabin. Had that tank been located inside the command module, the explosion would have killed all 3 astronauts instantly. As it was, it blew out a massive 13-foot panel on the outside of the ship, severely crippling their life support and power, but leaving them alive. For now.
Section 3. The Lunar Lifeboat. With the main spacecraft essentially dying, Mission Control is now staring down a brutal choice for getting the crew home. The fast return meant turning the ship around immediately by firing the massive main engine on the service module. But that engine was sitting right next to the blast zone. Firing it could literally blow the whole ship apart. The second option was the long return. Continue heading toward the moon, let lunar gravity catch them, and essentially slingshot them back toward Earth. It was mechanically much safer, but it would take 4 to 5 days. NASA's flight director made the call, take the long way. But the real question was, could they survive that long? The crew abandoned the freezing command module and huddled into the tiny lunar module. Now keep in mind, this craft was only ever designed to support 2 people for 20 hours while they explored the moon. Now it had to keep 3 men alive for up to 5 days. To save electricity, they had to shut down all non-essential systems, and yes, that included the heaters. It became brutally cold in there. Furthermore, they had to restrict their water intake to just 200 milliliters a day. And the reason why is absolutely wild. Drinking water meant producing urine, and venting urine out into space acts like a mini thruster that could actually alter their delicate trajectory home. The crew ultimately lost a combined 14 kilograms of weight, and astronaut Fred Haise developed a severe urinary tract infection.
But honestly, thirst and cold weren't even the most immediate threats they were facing. As they breathed, carbon dioxide levels in the tiny lunar module started rising to lethal levels. They used these lithium hydroxide canisters to scrub the CO2 from the air, but the lunar module only had enough for 2 men for 2 days. Now, the dying command module had plenty of filters, but there was a massive, ridiculous problem. The command module filters were square, and the slots in the lunar module were circular. Experts on the ground had just 24 hours to solve a literal square peg in a round hole problem. The astronauts radioed down a list of everything they had lying around the cabin: duct tape, plastic bags, cardboard, and hoses from their spacesuits. Ground engineers frantically built a prototype, tested it, and relayed step-by-step instructions all the way up into space. Commander Lovell later wrote in his book that the contraption wasn't very handsome, but hey, it worked. This brilliant, classic MacGyver engineering literally saved them from asphyxiation.
Section 4. The Long Way Home.
Surviving the cabin environment was really only half the battle. They actually had to fly this crippled Frankenstein of a ship back to Earth. To navigate, they had to fire the lunar module's descent engine, an engine that, by the way, was designed for exactly 1 burn to land on the moon. The first burn successfully slingshotted them around the far side of the moon, putting them an incredible 400,000 kilometers from Earth. That's a record distance for humans that stands to this very day. But their trajectory meant a 153-hour flight, leaving them with just a tiny 1-hour margin for their survival supplies. So they risked a second burn, shaving 10 hours off the trip. And then, surprisingly, they had to do a third burn. Why? Because the spacecraft was actually drifting off course due to the tiny thrust caused by cooling vapor venting into space. Incredibly, against all odds, the engine survived all 3 burns. Finally, after days of just freezing temperatures and severe dehydration, Earth is in sight. The astronauts moved back into the command module, which was the only part of the ship that actually had a heat shield, and detached the service and lunar modules. As they hit the Earth's atmosphere, the intense friction caused the air to ionize, completely blocking all radio waves. The entire world watched on TV, waiting in agonizing silence as the crew faced a fiery re-entry, with absolutely no one knowing if the explosion days earlier had cracked their heat shield. Usually, this radio blackout lasts about 2 to 3 minutes. So 3 minutes passed. Nothing. 10 more seconds? 30 seconds? A full minute went by. The tension in mission control was absolutely suffocating. Had they burned up? Finally, after an agonizing 4 minutes and 27 seconds, a voice crackled over the radio. The parachutes deployed. They had survived, splashing down safely in the Pacific Ocean. Apollo 13 went down in history as a successful failure. They didn't walk on the moon, but they proved the extraordinary capability of human ingenuity under unimaginable pressure. And it all leads back to this final thought for you to reflect on: how does a single, slightly dropped tank and a thermometer that couldn't read past 30 degrees completely alter the course of space history? It really reminds us that out there in the vacuum of space, the smallest oversight can become a matter of life and death, and that true exploration is just as much about surviving the unknown as it is about reaching the destination. Thanks for joining me on this explainer. Keep wondering, keep exploring, and